Good afternoon, class. Welcome to our very interesting topic today. So, we will be talking about linear regression. I think you have heard about linear regression. I think you have heard about mathematical modeling. So, we will try to get familiar with these terminologies. So, this has been a sunny afternoon. I just hope that you will feel good, that your day was already very nice since this morning. And I hope that you will be ready with this discussion for today. Can I have a thumbs up so I can see if you're ready for our discussion? Thank you, Janbert. Thank you, Justin Joy. Thank you, Joanne. Okay, let's start with our discussion. Let me share my screen. So I just hope that you can see this already. Now, our topic again is about linear regression. Okay. So, did you know that we make decisions about budgeting and other financial issues using linear models without even realizing it? That's correct. We call it real life problems, wherein we'll be using mathematics. So, in this lesson, we will use linear models, the basic ones in mathematical modeling. So the objective of regression analysis, which we will be using to analyze our linear models, is to predict or to do prediction or estimation of the dependent variable from known values of independent variable. We call it predictors. So for instance, a researcher like me wanted to predict performance in college with grades in high school mathematics, perception towards mathematics, empathy from previous mathematical class, experiences, and teacher qualification. I think you can also do it, no? You want to predict your calculus grades vis-a-vis some other grades, and this can be done using regression analysis. In regression analysis, you use equations to predict values of one independent variable from known values of one or more independent variable. Let me share a certain video so we will be able to have a bird's eye view of what regression analysis is. Okay.
What if we notice we sell more on rainy days? We might want to better understand the relationship between sales and rain to see if it's just a quirk in the data or a regular pattern that might help us better run our business. Regression analysis can help us explore the relationship between two variables. Are we actually selling more on rainy days? If so, is it possible to predict by how much? First, let's collect the data. The thing we're trying to predict is called the dependent variable. This number depends on the independent variable. The independent variable is something we already suspect has an impact on the dependent variable. Now we plot the data on a graph, where the x-axis is the independent variable and the y-axis is the dependent variable. Each dot represents 1 month's data, and we can see a pattern. We do seem to sell more in rainy months. But do we know how much we will sell if it rains 3 inches or 4? Imagine drawing a line that runs roughly through the middle of all the data points. This is the regression line. It will help us figure out how much we sell when it rains a certain amount. In practice, statistical software calculates it for us and creates a mathematical formula that looks like this. Remember, this is just an estimate. In real life, independent variables are never perfect predictors of dependent variables. That's why the formula includes an error term, which tells you how certain you can be. As statisticians like to say, correlation is not causation. It's easy to see a correlation between rain and sales, but it's different to say that rain causes the sales. Unless we're selling umbrellas, it's difficult to prove cause and effect. And don't let data replace your intuition. If you see something that doesn't make sense, investigate it. There could be errors in the data, or the relationship might be driven by other variables that we haven't looked at. One of the biggest advantages of regression analysis is the ability to look at how multiple independent variables affect your dependent variable. And that gets us closer to the kind of insights we need to better understand our business.
Okay, thank you, Vaughn. So in this discussion, we'll just be discussing about linear regression. Now, it will be used for us to be able to explain and measure underlying relationship between two or more variables. So it utilizes numerical independent variables in order to estimate the dependent variable. So this is actually a statistical technique, no, for finding out exactly which linear function best fits in a given set of data. As you can see, there is a table, no, is a figure wherein you can see there is a line and there are points. There are 5 points. So we can find out the equation of the regression line by using an algebraic method called the least squares method. So what is a least square method? It actually follows a certain formula, no? That is A is equal to y hat minus B times x hat. When you are going to solve for the y hat, we are just actually solving for the average of all the y. The x bar is the average of all the x. So all you have to do is to add. When you see something like e, no, you can see the something like e there. It means summation. All you have to do is to add all the values of x divided by the number of observation. Now, we also need to solve for the regression coefficient, which is uh, equal to b equal to ss, or the sum of squares of xy divided by the sum of squares of xx. Using manual solution, you have to multiply x and y and add all these products minus the summation of all the x times the summation of the y divided by the summation of the x squared times n minus the summation of the x squared. Well, this is the theory behind, no, but we will not be doing the manual computation because we have our GeoGebra. So the least square estimates in here, the values A and B minimizes the sum of square errors, which we call the least square estimates of A and B. And the resulting regression line is called the least square line from a given sample paired observation, x and y, where x is our independent variable, the y is our dependent variable. So the n is number of observations. So sometimes you call it the number of samples or respondents, okay? And then we have the regression line, y hat is equal to a plus bx. Now the y hat equal to a plus bx is what we call our linear model, or somewhat we call it generally our mathematical model, which are estimated using the least square estimates. So the formula is, again, we have this already, a is equal to y bar minus bx. So again, this is the mathematical model. Okay, so we are talking about the line or the least square line or the best fit line, which is the line that minimizes the sum of square distances. So let's have one example. I would like to show you how it was done using very fast I'd like to show you how it's done using manual computation. So as you can see, there is an x of 5 values of x, 5 values of y. So what we're going to do is to solve for a and b, and we need to have a regression equation of this data. And then we need to draw it and show this data in a scatter diagram. So when we expand the table, it will look like this. All you have to do is to multiply x times x, that is x squared, y times y, that is y squared, and then multiply x times y, and that's xi, yi. And then all you have to do is to add that and add everything. So all you have to do is to multiply x's, y's, and xy's and add. And then you can solve for the mean. I think you are already very familiar how to solve for the average or the mean of the x and the y. So using manual computation, we have to use this formula and then divide it with this formula, and then you will be getting 0.9. So thus the y-intercept is a equal to y bar, which is the mean of the y, minus b, or the regression coefficient, times the x bar. And that is equal to negative zero point 0.5. So now we will use the formula and then substitute it. You will have a plus bx is equal to negative 0.5 plus 0.9x. So this is our regression line with the scatter diagram. So this formula is our mathematical model, or shall we say our linear model. So that is the line which actually the best fit line for this set of data. So I would like to show you the different kinds of relationship. This is the linear relationship. I'm not talking about a romantic relationship here, but we are talking about linear relationship. Uh, and in this case, we have no linear relationship. Okay, so if you have a line which is parallel to x-axis, this is no linear relationship as well as a curve. But for a direct relationship where b is positive, you will have something like this. Okay, that as x increases, your y is also increases. And we also have something like this, which is very steep. Okay. And then we have lastly the inverse relationship when b is negative. So we have as x approaches the positive infinity, the y decreases. Okay, as a point goes to the positive infinity, or the x gets larger, the y gets smaller. Okay, and so with this. Now let's do it. So I told you to bring your laptop with you. I hope that you have your laptop. And then what you're going to do first is to open the Google. Do you have with you already the Google? Can I hear from Janbert?
Yes.
That's good. How about Joe and Ross?
Yes.
How about Justin?
Yes.
Okay, thank you very much. So at this point, all you have to do is to type Google Classic. Okay, please type Google Classic. And then if you have the Google Classic, you will have GeoGebra Classic. Kindly click this one. And then you will be directed to this Google GeoGebra.org. So we can see spreadsheet. Please click the spreadsheet. Are you following me? Okay. I just hope that you are with me. And then next is to encoded data. All you have to do is to go back. Can I have a virtual thumbs up if you are done with encoding? Okay. Thank you very much, Justine. Thank you, Janbert. Thank you, Joanne. Okay. So if you're done with the spreadsheet and encoding, you will have to drag this column to that, and then after that click to variable regression analysis. Okay, and then after that you will have to click below where you can see regression model. Click here, you will have linear, click linear, and then you will be having this graph. The line in red is your regression line model, or the regression line. Okay, now for example, you would like to predict the y. Kindly write x below. You can see x is equal to, kindly write x 6 and tell us what you got. You can write in the chat box, okay, if you got it correctly. Okay, thank you. Okay, Janber got it right. Joanne got it right, as well as Justine. Thank you very much. But I would like to emphasize that you cannot just do linear regression, even if you just would like to do it, right? But there are several assumptions. One is that it uses independent and dependent numerical variables. It's numerical. Next is it should be based on the linear relationship assumption that relationship exists between dependent and independent variable. If it's not, then we cannot use linear regression analysis. Third one is to assume that the dependent variable are normally distributed. So there is a test on that to be able to determine if it's normally distributed. When we say normal distribution, you can have a bell shape. Okay. Now, it also assumes that the variances of the dependent variable are assumed to be equal given different values. Okay, let's do this. I think you are excited to do it again. So regression. Now, I would like to ask Joanne. Joanne, can you share with us your screen? Can you tell us something about what you did?
I placed the X in A and Y in B.
Okay, so I think you are on the right track. So please continue writing the x and the y. Okay. So when I do it manually, you will have something like this. So, did you get the same answer? 16.63 plus 1.54x. Okay, can I have a virtual thumbs up? Okay. Now, if you will try to substitute x with 11, you will have how many? Can you write it in the chat box? How many motorcycles if you have 11 years? Yes, that's correct. 34 motorcycles. Okay. Very good, Joanne. Very good, Janbert and Justin. You got it correctly. Now, I want you to do this again. Now, again, in code here, the chemistry scores and the counting scores. Maybe I can ask somebody later, no, to show the mathematical model. Okay. Any volunteer would like to share screen?
I will volunteer.
Oh, it's Joanne again. So thank you, Joanne, please. Um, there was a question about what is the score if your maybe we can ask somebody if you got the same thing. What about Janbert or Justin? Did you get the same thing, please? Can you tell us?
Yes.
How about Janbert?
Yes,
How did you do it? Did you have the same answer? Can we hear from you?
I've also got 70.9419 in my Y value.
So I think that's the end of our discussion for today. Now I would like to hear from you. Okay, anybody would like to answer the first question? Let's have a recap. In your own words, what is linear regression? Okay, and how will it possibly applied in the real world? Anybody can answer that.
Um, Linear regression is a way to help us see relationships between two variables by fitting a linear equation to the data. It can be applied to the real world by using this method to quantify the relative impacts of age and gender, or to help us predict prices and help us budget our money.
Wow, thank you very much, Justine. Okay, that's very nice to hear. How about, did you hit your learning goals for today? Anybody?
It did hit my learning goals today because I was able to learn about the simple linear regression using GeoGebra.
Thank you very much, Joanne. That's Joanne. What about your realization for today's lesson?
My realization for today's lesson about linear regression is that it is helpful in knowing the relationship between two or more variables and in predicting the value of one dependent variable. By using data, the data that has been gathered, and you can easily get the value of the dependent variable by using the software GeoGebra Classic.
Thank you very much. So I'm so happy that you have learned something for today. So I think that's the end of our discussion for today. Thank you very much. I would like to see your faces. If you are happy, please give us a thumbs up or a smile maybe. Okay, thank you very much. Thank you, Joanne. Thank you, Janber. Thank you,